So there are three different ways that you can calculate density altitude. The density altitude formula, a flight calculator like an E6B, or a density altitude chart. Keep in mind, as we discussed in our last session, that a standard atmosphere is a temperature of 15 degrees Celsius or 59 degrees Fahrenheit, a pressure of 29.92 inches of mercury at sea level, and a lapse rate of 2 degrees Celsius or 3.5 degrees Fahrenheit for every 1,000 feet of altitude gained. The density altitude formula looks like this. So this equation says that density altitude is equal to pressure altitude plus 120 times the difference between outside air temperature and standard temperature. So let's say we have an outside air temperature of 25 degrees Celsius and a pressure altitude of 1,155 feet. The number 120 in the equation represents the average increase in density altitude for each degree Celsius above standard temperature. And just to review, if we're talking about that standard temperature, which is 15 degrees Celsius at sea level and decreases 2 degrees Celsius for every 1,000 feet above sea level, then at 1,000 feet MSL, the standard temperature would be 13 degrees. At 2,000 feet, it would be 11 degrees, and so on. So if the outside air temperature is 25 degrees Celsius and the pressure altitude is 1,155, what is our density altitude? First, we calculate the ISA temperature. So standard temperature change equals pressure altitude divided by 1,000 times 2. So we divide the pressure altitude by 1,000 and multiply that by 2 to get the standard temperature change for that altitude. In this case, it would be 2.31 degrees Celsius. We subtract 2.31 degrees from 15 degrees, and that gives us the ISA temperature of 12.69 degrees. Next, we subtract the ISA temperature from the outside air temperature. In our case, that would be 25 degrees minus 12.69 degrees, which equals 12.31 degrees. Multiplying that by 120 gives us 1,477.2 feet of increased altitude. Adding that to the pressure altitude of 1155 feet gives us a density altitude of 2,632.2 feet. Since performance charts are usually in even thousands of feet for your check ride, we can round up to be conservative and say 3,000 feet. Now we can do it using an E6B calculator. I'm using this online one because my paper one died. To use the calculator, you still need to use your pressure altitude and outside air temperature. Let's use the same numbers so we can compare the results. Line up the pressure, altitude, and your outside air temperature. Here you can see that we lined up 25 degrees Celsius and approximately 1,150 feet, or where that should be. Now, read the density altitude next to this arrow. It appears to be just over 2,500 feet. So for your written test, we would want to calculate that as precisely as possible. For the practical test, we should usually round up to be conservative, and we can say 3,000 feet. Now, let's use the chart that comes in the private pilot written test supplement. We start by finding the outside air temperature along the bottom part. Then we draw a line straight up from the temperature to where it crosses the pressure altitude line. We draw a horizontal line all the way across and read the density altitude on the scale on the left of the chart, which looks like it's closer to 3,000 feet. So you can see that all the methods yield pretty similar results. And that is calculating density altitude.